This is Bryan Salva, and today I'm going to show you how to find the radius of convergence and the interval of convergence in a... Hi, this is Bryan Salva, and today I'm going to show you how to find the radius of convergence and the interval of convergence in a series equation. I'll be showing you this through this example, where we're going to find the radius of convergence and the interval of convergence of the summation of between 1 and infinity of okay. Hi, this is Bryan Salva, and today I'm going to show you how to find the radius of convergence and the interval of convergence. Hi, this is Bryan Salva, and today I'm going to show you how to find the radius of convergence and the interval of convergence. Hi, this is Bryan Salva, and today I'm going to show you how to find the radius of convergence and the interval of convergence of a series equation. We'll be doing this by using this example, by going through this example, where we have to find the radius of convergence and the interval of convergence of the series equation between 1 and infinity of the factor of x plus 2 to the power of n over n times 4 to the power of n. The first thing you can tell is that the center of convergence, or pretty much, center of convergence is pretty much -2, according to the top. Now, to find the radius of the convergence, we are going to set this up like a ratio test, where the limit as n goes to infinity of the absolute value of a n plus 1 over a of n, where in this case would be limit as n goes to infinity and the absolute value of n plus 1 times 4 to the power of n plus 1 under the factor of x plus 2 to the power of n plus 1 times n times 4 to the power of n over the factor of x plus 2 to the power of n. Okay. Using our laws of using the rules of powers, we can cross out 4 to the power of n and x plus 2 to the power of n, which will bring us to the limit as n goes to infinity, the absolute value of factor of x plus 2 over four times n plus 1. Now we can simplify this even more. The having it equal to the limit of n goes to infinity of n, the factor absolute value of x plus 2 over 4n plus 4. Now let's find the limit. Okay, the limit of this, as it looks like right now, would be infinity over infinity, enabling us to use the L'Hopital's rule. So now we have to find the limit of as n goes to infinity of x power of x plus 2, the absolute value of x plus 2 over 4, which is x plus the absolute value of x plus 2 over 4, which should be less than 1. This will lead us to our radius of convergence. Continuing multiplying the 4 on both sides, we find that our radius and convergence is 4. Now to find our endpoints of the interval of convergence, we will have to recognize that with this radius, this can become this, and then we subtract 2 on all 3 sides. So pretty much our interval will be -6 of unknown convergence, absolute of x, and 2 of unknown convergence. Though we need to find how. Though right now we don't know the convergence at these 2 points. So our integral looks more like is more of a mystery, though we have a rough idea. So now let's plug in the 2 values to find the convergencies. Sorry, where x is equal to -6, you find that the summation between n is 1 and infinity is -6 plus 2 to the power of n over n times 4 to the power of n. We can simplify this to equal to series between 1 and infinity to -4 to the power of n over n times 4 to the power of n here we can see that this is basically this, but as a negative, which can be simplified to the series as 1 goes to infinity of negative 1 to the power of n over n and as you can see, not only is this at this point the series and the x equals negative is that the series is alternating, and not only that our equation is p series, but also it's a special kind of p series that we call a harmonic, harmonic equation, where it's summation, where it's an 1 of 1 over mp, where p is equal to 1, which is basically what's going on up there. So we know that where x is equal to negative 6, it is divergent by p series. Okay, so now let's find the one for 2 with the same process. Series of infinity and series of 1 to infinity of 2 plus 2 n to the power of n over n times 4 to the power of n equal to series between 1 and infinity of 4n over n 4 to the power of n, 4 to the power of n, and these two cancel each other out to get us the series between the 1 and infinity of 1 over n, harmonic series again. So we see that at this point it is also divergent by p series. Now we can conclude that our interval in convergence is negative 6 x to 2 and they are divergent on both sides. Sorry, I forgot how to explain that. It's been a while. My head's been kooky. Okay? Thank you for watching, and carry on.